what what I'll try to do today is, statistics is quite confusing, and to the people who have forgotten a bit during the undergraduate days, so I'll just touch upon the main thing, concepts. The whole idea is to see what you are able to write in your synopsis, what you should be able to write in your synopsis so that it does not come back. Okay. So what should you be able to do at the end of the session? In your synopsis, you should be able to describe how you will carry out the statistical analysis, elucidate the sampling methods and sample size. And if you are doing randomization, then what is the method of randomization that you are doing? So that is what you should be able to do. So let us start with the things. First, descriptive statistics. So in the presentation and organization, summarization of data, that is, in your sample, so many people are diabetic, so many are not diabetic, so many are male, so many are female, HbA1c level or so much. So you are telling what is happening in your data, that is called as descriptive statistics. Second is inferential statistics. So you are telling, from my sample, can I generalize it to the rest of the people, diabetics? That is inferential statistics. So there you use terms such as confidence interval. Then when you are applying various statistical tests, that is when you are applying inferential statistics. Now, I think some of you might be knowing this. What is a variable? A variable is something that you are measuring, what is being observed or measured. Now, what is a dependent variable? So outcome of interest. Let's say that I am giving a particular drug and I'm finding out the fall in HbA1c level. Then your dependent variable is fall in the blood sugar level or HbA1c levels. What is your independent variable? The intervention that you're doing. Whatever treatment, metformin or whatever treatment that you're doing is the independent variable. Sometimes they use the word predictor variable and outcome variable. So let's say that you are saying that age, gender, smoking are predictors of myocardial infarction. So that is the predictive variable, and the outcome variable here is myocardial infarction. So now let's come to types of data. Now, why we should know types of data? Because how you are going to summarize and what statistical test to apply, it depends upon the types of data. So you can have discrete or continuous. Discrete is you can't have 3.5 children, no? So you are having round numbers. That is called as discrete variables. Well, continuous is, it can take any value in between. So let's say blood sugar, it can take any value in between. That is called as continuous variables. Now, qualitative variables and quantitative variables. Let's look at blood sugar. Let's say I say hypertensive, not hypertensive. That is just naming. These are called as nominal categories. And I can put hypertensive first, not hypertensive first. It doesn't matter. So these are called as dichotomous, where only two values are there, male, female. You can have also polychotomous, that is blood groups, A, B, O, AB, religions. So many categories are there. The next is ordinal variables. Now let us say, I say no hypertension, mild hypertension, moderate hypertension, and severe hypertension. When I do that, there is an order among these categories. And that order, the difference between the categories may not be equal. So let us say that I say no hypertension, mild hypertension. What is the difference? It might not be equal to mild and moderate. Or let's say fail, pass, first class, and distinction. The difference between the categories may not be equal, but there is a certain order. I can't take out moderate hypertension and put it below no hypertension. So ordinal can be qualitative ordinal or quantitative ordinal also. Now let's come to the next is quantitative data, where you are measuring. I am measuring actual blood pressure. That is quantitative data. Okay, interval and ratio scale, you don't bother too much about it. The type of data dictates the statistical test and the way the data is going to be summarized and presented. So that is what you have to remember. So first thing that you should do is what is the type of data. So that is what you should remember. How do we summarize data? Central value and variability, that is mean and SD. Or if it is qualitative data, you say percentage. Now, what I'm going to do is, I'll be in between, I'll be telling you how you should write this in your synopsis. in between, after the concepts, I'll be telling you how to should write the thing in your synopsis. So measure of central tendency, all of you know. If I have to tell, I have to tell a single variable, and then I have to tell how the data is distributed. So mean, median, mode, all of you know. I'm not going to go into the details. Now, if I go into the measures of variability, you have got range, that is the maximum value minus the minimum value. Then you've got interquartile range, mean deviation, variance. Standard deviation is a thing that you are most likely to use. Okay, so standard deviation is one word that you must know. And the square root of the variance is the standard deviation. Now you come, what we talked about before was what is there in your data, in your sample. Now, when I'm looking at, if I take a sample, let's say we are looking at the IQ of all the postgraduate students that are there. Now, if I take the sample of the people in DY Patil and I get a mean IQ of, let's say, 120, is that the IQ if I do in some other medical college? Am I going to get 120? No, it might be different. So, if I samples vary from each other, and if I take sample means, then so you have got standard error of the mean, standard error of difference of the mean, standard of proportion, standard error of difference between proportion. Why you should know this? Because this is useful in doing tests of significance. The t-test and all the tests that you do will use this. Just know the concept. No formulas need be remembered. So we know if you arrange the sample means, they'll follow normal distribution. And what is standard error? Standard error is standard deviation of sample means. Now, the standard error is given by the formula of SD upon root of n. SD upon root of n. Now, if I take SD upon root of n, if I want to reduce standard error, what should I do? Usually, I should increase sample size. Usually, I should increase sample size. So, let's say that I have got the blood pressure mean is so and so, the standard deviation is so and so, and the number is so and so. So if I want to calculate standard error, I can calculate it by can you mute yourself? Because I think someone, some people are. Okay. So I can calculate standard error and plus or minus 2 standard errors. Actually, it is 1.96. The mean plus or minus 2 standard error gives me the 95% confidence interval. Just keep it at the back of your mind. Okay. Hypothesis, to a certain extent, Dr. Banerjee took this. So it is a statement about a population or populations. And you should make the hypothesis such a way that you can test it, so that you can accept it or reject it. For example, let's say I say smoking more than 5 cigarettes per day in men about 20 years for 10 years is associated with an increase of lung cancer. This is what I have got in mind. Now, usually you can't prove a hypothesis. So we set up a null hypothesis. This was there during undergraduate days also. So, and the hypothesis should be stated in advance. So the null hypothesis forms the basis of statistical significance. And what we are saying is smoking more than 5 cigarettes per day is not associated with an increase of lung cancer. And the alternative hypothesis is what you had thought of before. What is your research question? So that is your alternative hypothesis. Then you've got something which is called as one-tailed and two-tailed hypothesis. If I say that drug A is better than drug B, then that is a one-tailed hypothesis. If I say drug A is different from drug B, then that is a two-tailed hypothesis. Drug A can be better, drug A can be worse. So that is a two-tailed hypothesis. By and large, in statistics, we do two-tailed hypothesis. Now, what are the steps in hypothesis testing? This you did during your UG days. You have to state your alternative and null hypothesis. Type 1 and type 2 error. Yesterday, we had covered that. Collect your data, then calculate this type, apply this test of statistical significance, and then interpret it. Yesterday, Dr. Banerjee had told you that what is a type 1 error? The type 1 error is an incorrect rejection of the null hypothesis. And the type 2 error is failure to reject the null hypothesis. Now the type 1 error is a very serious error. So the type 1 error is usually kept at 0.5. It's also called as alpha error. How do you reduce it? Increasing sample size. Type 2 error, not so serious error. It is called as beta error. Kept at 0.2, usually kept at 0.2. Again can be reduced by increasing sample size. And if you do 1 minus beta is called as power. So we say 80% power. 80% power means you have assumed type 2 error as 0.2. Now I come to test of statistical significance. I will not go into the details of the various tests, just understand the concept. So the basic test is signal upon noise. Suppose you are going in your car and you are listening to a song and your aim is to identify that song. Now if the signal is very clear, you can identify the song very easily. But if there is a background noise, khar khar ho raha hai piche, then it takes time for you to identify that song. Similarly, if you are comparing two drugs and if the two drugs are producing marked difference between the two drugs, let's say that one reduces blood pressure by 20 millimeters and the other reduces just by 2, then your signal is very strong. But let us say one reduces by 20 millimeters and the other reduces by 19. Now your signal is very weak, is not so strong. Then next is noise. Noise is standard deviation or standard error. Some people will improve, some people will not improve so much, some people may not improve at all. So this is what is the basic test is signal upon noise. And remember, statistical association does not mean cause and effect relationship. Now, just remember the sum of the tests that you're going to use, because this is what you're going to write in your synopsis. So for quantitative data, you have got unpaired and paired t-test. Unpaired t-test, I have got two groups and I'm comparing the means of them. That is unpaired. Paired t-test, I have got one group and before and after. I'm doing before and after measurements and then I'm measuring the mean and SD of blood pressure, for example. That is a paired t-test. If I have got three groups, then it is ANOVA. If I'm measuring three different groups, then it is ANOVA. If I am doing, instead of doing before and after, I'm doing before, 1 hour after, 3 hours after, 4 days after, something like that, then you use something which is called as a repeated measures ANOVA. In addition, if you are looking at the association between two quantitative variables, for example, I'm looking at BMI and I'm looking at blood sugar, both are quantitative variables. Then I do something which is correlation degree coefficient and regression coefficient. Now for qualitative data, you have got chi-square test. Commonly used test is chi-square test or Z test, and Fisher's exact test if the numbers are small. For ordinal data, that is if the data is not normally distributed, then I have got something which is known as Mann-Whitney, Kruskal-Wallis, Wilcoxon-Sign rank, and I have given the, for the paired t-test, it is the Wilcoxon-Sign rank. For the Pearson's correlation coefficient, it is Spearman's correlation. And for the repeated measures, it is Friedman's test. Just remember the names and where they are being used. Are they applicable to your study or not applicable to your study? So, okay. So I'll just show you one test that is a t-test. Let's say I'm using two drugs to find out reduction in blood sugar, HbA1c, for example. And I have, so what is the signal? The difference between the two means. What is the noise? The noise is the standard error. That is, some people will improve more, some people will improve less. So when we are not going to use this formulas, statistical analysis is done by packages. We should know what goes into that. For example, here I find out that the mean is 17.7 and the other is 22.2. So the group 2 has got a higher mean as compared to group 1. And then you get the t value, degrees of freedom, and p is less than 0.007. So it is less than 0.05. So it is statistically significant. So how do you write? Now this is what is important. Under the plan for statistical analysis, what are you going to write? You will say data will be entered in Excel and analyzing using whatever package you are going to use, whether it is APinfo, SPSS, MedCalc. Quality data will be summarized. First thing you'll write how you are going to summarize the data using proportions, percentages, and quantitative data in terms of mean and SD. So this is what you're going to write in your synopsis. Appropriate test of significance such as chi-square t-test, pair t-test, ANOVA depends upon what is applicable to you. No, don't write all of them. Write what is applicable to you. And you will say that p less than 0.05 will be considered as statistically significant. So this is what you're going to write in your synopsis. Next. So we have covered plan for statistical analysis. Now we come to sample size and method of sampling. Now, why do we use samples? Put it in the chat box. Why do we use samples? Why do we use samples? And not study everybody. Why not study everybody in the population? Why are we using samples? Yeah, put it in the chat box. Why do we use samples instead of studying everybody? I can see no response. Yes, someone has written not feasible, time consuming, very right. Anything else? Easy to infer about population. Yes, if you have collected the sample properly, then yes, easy to infer about the population. Okay. To study the at risk of population. Okay. So these are the some of the reasons. So why we basically, when we come to samples, is suppose I can study properly. Suppose a small number of people, I can do the test properly. If I have to study everybody, it's not possible for me. I will be able to do it more precisely and more better. Then the other ethical issue. If I have to do certain sample size is required, I should not use more than what is the sample size recommended, because they potentially might be exposed to harm in research. So that's the reason why we use samples. Okay, so we have said that why do we use samples? Then definition of samples is you take a small number of people, so you select them as representatives of population. This was told to you previously. We want to study all diabetics, but I can't study all type 2 diabetics. I can study only those who are available in Pune or in my field practice area. So how do I get access to them? I need a sampling frame. I need a list of all the people. This is called as a sampling frame. From them, I select by some method, I'll select few people. That is called as sample. Sampling unit. What are you measuring? Are you measuring an individual? Are you measuring a household? My dental colleagues use one tooth as a sampling unit. My eye colleagues use one eye as a sampling unit. Next is sampling fraction. Suppose out of 1,000 people population, I take 100. My sampling fraction is 10%. Sampling frame is a list of all the sampling units in the population. Now, type of samples is non-probability and probability samples. Non-probability is no known probability. We don't know what is the probability that we have. So probability of being chosen is unknown. One is quota sampling. Quota sampling is there are 70% Hindus in the population. So in my sample, I'll take 70% Hindus. How I select those 70% is different. The next is convenience sample. Most of us do this. What is convenient to us? They are easily accessible to me. So that is why I do that. So that is called as convenience sampling. It may be biased. Then you can have purposive or judgmental sampling. I want 70%. I want severe people also, moderate severity also, and mild severity also. So that is my judgment. So that is the way that I take. Okay. I am not going to the rest of the types of samples. Then probability samples. Now here each subject has a known probability. So selection bias is reduced. The investigator cannot decide who is going to be selected. Okay. So you can apply statistical theory to it. Sampling theory. Now, as I told you, let's say that I take an IQ and I want to select a sample. So you are going to have standard error of the mean or standard error of proportions. Now we know that if I want to reduce the sampling error, then I should increase sample size. And we know that actually sampling error is not sampling, it is an error. Actually, in the nature of sampling, it is like that. So now what are the methods used? One is simple random sampling, systematic sampling, stratified sampling, multi-stage sampling, multi-phase, and cluster sampling. I'll take only a few of them. Simple random sampling. So what I do, I make a list of all the people, and from them I randomly draw. Like make chits, let us say, and I draw chits from them. Or I use computer generated tables or random number tables. This is called as simple random number sampling. But for that, I must have a list of all the people, or simple random sampling. Now, systematic sampling. I take every nth person. For example, let's say I want 1200 school children. I want to take 60 children. So my sampling interval becomes 20. I take any random number between 1 and 20, and then I keep on taking every 20th person. So I take 8th, then I take 28th, then I take 48th, and so on and so forth. This is called as systematic sampling. Now this is stratified sampling. Oh, I want mild cases also, moderate cases also, severe cases also. So what I'll do is I will stratify them, and then I'll take sample from each of the strata following random technique. This is called as stratified sampling. The rest of the sampling techniques I'm not covering in detail. Cluster sampling, mostly the community medicine people will do. Nobody else does. Most of the other people don't do it. So what do you write in your synopsis? What under this thing you'll say method of sampling. If you are using convenience sampling, say convenience sampling will be used. For example, let us say RHT, Rural Health Training Center. So we have got household folders. From the household folders, families will be selected by simple random sampling. Now, or let us say you are doing a study on rheumatoid arthritis. So you say from previous records, it is noted that 200 patients are admitted in each year. My sample size is 50. So I will select this 50 by systematic random sampling. So I'll take every fourth person. This is called as systematic random sampling. Now, if you're doing an RCT or a comparative study, you don't have a list of the people at the beginning, isn't it? You don't have a list at the beginning. You don't know how many patients you're going to get. So you can say all consecutive patients who meet my eligibility criteria, and it will be applicable to most of intervention trials. Most of the people who are doing intervention trials will, so all consecutive patients who meet the eligibility criteria and agree to take part in the study will be included till desired sample size is achieved. This is a method of convenience sampling, but this is the way that you can write in your method of sampling. So we have covered how to write method of sampling in your study. Now, under the heading randomization, where applicable, can you tell me what is the difference between randomization and random sampling? Put it in the chat box. Randomization and random sampling. So how do you do that? Put it in the chat box. What is the difference between randomization and random sampling? Sai Mahesh has given the correct answer. So the randomization is applied after you have selected your sample. So randomization is a method of allocation to the allocating to the different arms. So somebody is going to the control group, somebody is going to go to the experimental group, but that it is not in your hands. So first you have selected the sample and then you are allocating that by random. So what do you write? You write the participants will be allocated to the different arms using a computer generated sequence, or you can write cheat method, whatever is the method that, or random number table method, even and odd, that sort of stuff. So this is under the heading of randomization. If you are conducting an RCT, then this is what you have, or if you are doing a treatment arm, then this is what you are going to write under randomization. I think Archana Buch ma'am has already told you that most of the times the ethical committee here does not allow RCTs. Okay. Now we come to sample size estimation. Now this is the reason why most of you come to the statistician. And this is the reason why most studies are sent back from the scientific committee. So now, what sample size should I have? So this is the main reason why statistician is consulted. So let us say now, estimating sample size is like asking how much money you need on a vacation. So how large a sample size is like how much money is needed on a vacation. Now, can you tell me how much money is needed on a vacation? What are the different things that you should consider when? So how much money is needed on a vacation? Put it in the chat box. How much money is needed on a vacation? So what does it depend on? How much money is needed on a vacation depends on what? Okay, Akhil has written that it depends on the amount of money that is available. Duration of stay. Which are the places that you're going to write? Correct. Akhil has said that. Any other things? Any other things? Yeah. What is our capacity? Your drink budget. Yeah. Very right. Whether your income, whether you're going with your boyfriend or girlfriend, or you're going with your wife or girl, boyfriend or girlfriend or husband and wife, whatever it is. So the thing is, it depends. So how large a sample size also depends. It depends. So it depends on what? It depends on what? Now you tell me, what are the factors that you should consider when what sample size is depend on what? Put that in the chat box. What is the sample size dependent on? How much sample you are going to study depends on what? Okay, incidence prevalence. What else? Feasibility. Gayatri has said feasibility. Any other comments? Any other comments? So really speaking that, so burden in the community. So whether it is an important public health or a problem. So all these things. So when you are looking at how much sample size is needed, basic thing is feasibility. How many patients, how many subjects are available? I might give a sample size of 1,000. And if there are only 100 people available, how are you going to carry out the study? What is the cost? I mean, that you have to consider it. No, suppose some of the investigations you have to do it from your own pocket. So you have to look at what is the cost. What is the time required? You should be able to carry out the study within the given time period that is available for your PG dissertation. What are the other resources? For example, you want radiological investigations, you want MRI, whatever is lab facilities. So you'll have to think of that also. You'll have to think of all these things when you're looking at sample size calculation. So first thing is important is feasibility. I have had people in the past who I had one, I won't name the department, one person came and he said that he had around 20 people, and yeah, I think there were only 20 people he had studied, and he showed it as 100, made up all of that. Fake data is one thing that you should never do. Fake data, you know that people are caught because of fake data. That is other thing, but your conscience should not permit you to do it. So sample size considerations, you will have to look at this. So what will the statistician, when you go to the statistician, what are you going to be asked? You cannot go with your hands in your pockets and say, mere ko sample size bata. No, you will have to take your hypothesis, your objectives, how you are going to carry out. So that you have to carry out. Then what is the effect size signal? What is the mean and SD of this group? What is the mean and SD of that group? So what is the effect size? If you are comparing two groups, for example, percentage of improvement or percentage of prevalence in one group, percentage of prevalence in the other group, side effects in one group, side effects in the other group. What is the variability? What is the SD, standard deviation? Alpha, beta, usually the computer fixes it at 0.05 and beta is 0.2. So that is usually fixed. So this is when you are comparing two groups. But if you are looking at when there is no pre-specified hypothesis, I want to find out what is the percentage of diabetes in the community. Now, if I want to find out what is the prevalence of diabetes in the community, then I must know what is the prevalence of diabetes in the community. What is the margin of error acceptable? Now, let us say the prevalence of the community in the community is 20%. Then I can fix the margin of error. I'm ready to accept an error of 5%. So it can be 15%, it can be 25%. If I get in my study, it is acceptable. And I have to give the confidence level. that confidence level is usually kept at 95%. So this is what the statistician is going to ask you when you are going to go and ask for sample size. So take 2 or 3 studies along with you, because it might happen that one study, if you take one or two studies and you're finding that your sample size is not being met, that it is too much, you want to reduce the sample size or something like that, then you'll have to have another study to back it up. Sometimes what will happen is you might, in one study, something is there, in the other study, some other method. One method is not, both the methods are not there in one study. So you can use 2 studies also for that. That is allowed. That is allowed. But you must have studies to give you this. So select the studies and go with those studies. Many times people come to us and they have not done the review of literature. And they'll say, oh, kisi ne kiya hi nahi abhi tak. So try to get the studies. Then only your sample size can be given. Now, remember, sample size is based on statistical that is used and not on only on prevalence. If it is a prevalence study, then it is based on prevalence. But if it is based, let us say, difference between two groups, t-test, it will be based on sample sizes based on t-test. Also remember that when you are calculating sample size is calculated for each objective. And you take the maximum sample size that is allowed, but that is feasible, or that is there. But what usually we do is at least one of them you calculate. Okay. Now, I will rightly said, have an idea how many participants would be available and manageable. Because this is a question that we are going to ask you. How many patients have you got? How many patients can you do? Honestly do. That is what we are going to ask you. So you should be prepared with that answer. Okay, find out from the previous record, ask your guide, ask your other people, how many patients are you likely to get? Will they be available in DY Patil? Do we have to go outside? So ask that. What if there is insufficient information? As I told you, some people will come and they'll say, sir, iske baare mein koi information hi nahi hai. No, if you come and say that no information is available, then you are going to have, it is difficult to calculate sample size with that. No. So what we will do is, we'll ask you to read it again. And many times in front of us also, we will search for the literature and we are able to find it. Suppose there is nothing. Suppose what has happened is, I'll give you a similar this thing. Like when I wanted to go to the medical college, I really speaking, I did not want to go to medical college. I wanted to go to an engineering college. So my mother says to me that when you were born, your father said that this chap will become a doctor. Ye bada hoke doctor banega. So I got blackmailed sentimentally and I became a doctor. Now, similarly, your guide will say, मैं तो कुछ इतना कुछ खास कर नहीं पाया, but मेरा शागिर्द जरूर कुछ earth shaking discovery करेगा. So if they give you an out of the way topic which nobody has already done before, then you are going to land up with a problem. Then you don't have any basis on which to calculate sample size. Not only that, what are you going to write under review of literature? Because if nobody has done any study, then what are you going to write? So usually what we do is, the MD is just a passport to getting your, the dissertation is a passport to getting your MD. So we usually use what studies have been done before in some other country, in some other place. But if nothing is available, then you have to do a pilot study. Pilot study, do on some small 5, 10 people or something like that. Do a small study on that, and using the data that is generated by the pilot study, the mean, SD, and so on and so forth, calculate the sample size. So that is the other method of when you are doing the pilot study. The last is an educated guess. Some of the studies you will find, assuming that there will be so much improvement. But by and large, scientific committees, the members have also undergone some sort of course that you are undergoing. Okay, research methodology. So they want something which is written, which I'm going to tell how many you write samples. They want something like that. Okay. Now, the next is sample size based on feasibility. So here what you are saying is that I am doing a study on rheumatoid arthritis, and I want to study what are the different markers in rheumatoid arthritis. some of the markers are have not been studied previously or whatever it is. For me, there are 50 patients which are likely to be available during my study, which are based on previous this. So, and that is within my resources. So I am going to use 50. So sample size based on feasibility is an honest this thing. Many people don't use it. So this is one more reasoning for sample size based on feasibility. Now, what if sample size is too large or too small? Your comments. What if the sample size is too big, or let us say too small first? What if the sample size is too small? Yeah, you can put it in the chat box. What if the sample size is too small? What will happen if the sample size is too small? Yeah, I want other people also to respond. Okay, what if the sample size is too small? Okay, correct. The conclusion cannot be mapped to a larger population. Correct. You cannot draw valid conclusions. Incorrect outcome. You might not be able to come to a correct conclusion. Also, yes. What else? Error. What error? Increasing the margin of error. The standard error becomes more. Very right. The standard error becomes more. So what happens? So what happens? If the standard error is more, what happens? If the standard error is more, then you will not be able to get statistical significance. So the postgraduate students are like, they are like patients, relatives of a patient who is just admitted to ICU. While when the patient is newly admitted, the relatives say, sir, इसको कुछ भी करके बचा दो, मैं घर बार बेच दूंगा, सब कुछ बेच दूंगा, मैं अपने आप को भी बेच दूंगा, हाँ, लेकिन आप इसको बचा दो. When the patient is being discharged, they look at the long list of bill that items that have been done. ये आपने को किसने करने के लिए बोला था? So now they start complaining, and this is what the PG students also do. When they come initially to us, they'll say, "Sir, sample size छोटा करो ना, और छोटा करो ना." When they come to us for analysis at the end, they will say, "Sir, इसमें कुछ भी तो significant नहीं आ रहा है." अरे, if you have got a small sample size, it is not likely that you're going to get statistical significance. That is the risk that you're taking, no? So that is the problem with if your sample size is too small. Now, what is the problem if the sample size is too big? Yeah, put it in the chat box. What is the sample size is too big? What is your problem? You have got a very benevolent parents who say that, "Bachche, don't bother. You can spend as much as you want. You can do as much as you want. Spend as much as you want. Take as much sample size as you want. We are ready to fund it." What is the problem with sample size which is too big? So won't be able to complete in stipulated period. That is one response that I got. Anybody else? What is the problem with a too big a sample size? Small differences are statistically large. Very correct. Absolutely correct. So let's say that we have a competitor of Baba Ramdev who makes a hair oil, and that hair oil increases your hair length by 1 millimeter. And that person uses a sample size which is 1 million. It is going to be statistically significant. So clinically insignificant results become statistically significant. That is one major problem if you have got too big a sample size. The second thing that happens with too big a sample size is ethical issues. I told you that especially when you are doing intervention trials, you cannot have a sample size which is more than what is actually required. So you will have to look at what are the ethical issues. So sample size, that is why it is like playing a game, and we are laying down the rules beforehand that this is the sample size that has been calculated, and we are going to assume that, and with the assumptions, and we'll carry out our study. Right. So now I give certain formulas. Just look at it. Some people ask for these formulas. Most people don't. I do not use these formulas. Okay. For prevalence studies, these formulas are prevalence studies. For prevalence studies, it is 4 pq upon L squared. That is actually 1.96 squared, where P is the proportion. For example, diabetes mellitus, P is 20%, Q is 100 minus 20, that is 80%, and my allowable error is 4%, let us say. That will give me the sample size. For quantitative data, let us say hemoglobin, standard deviation is 2. So I use 2, and allowable differences in the mean is, let us say, 1. So I use this. So since these formulas are very complicated, I will show you certain simpler formulas which you can see and forget. Okay. So basically remember that we should know what goes into that. So what goes into the formula is effect size. In the denominator, you have got effect size, the difference between the means. What goes into the numerator is variability. It goes variability and what is the power of the study and what is the alpha error. That is, what is alpha error and the beta error. Similarly, for proportions, you have got certain formulas which we will just see and then forget, because normally we use packages to calculate the formulas. Now, how do you write in your synopsis? In the sample size, how do you write? So let us say we have got a prevalence study. We say, considering a prevalence of 3.8%. For this, you have to refer to an article and you have to give the reference of the article at the end also. So considering a prevalence of 3.8% for diabetes in rural adults with an absolute allowable error of 1.5%, 95% confidence level, the estimated sample size was 625. The statistical package use of ZenPepi, depending upon whatever package you are using. This is what you are going to write in your synopsis. So for sample size calculation, you can come to our department and then we'll help you out with this. Next, suppose it is a difference in means. I'm just giving 2 examples. Now, let us say a previous study showed mean fall in HbA1c levels after a 26-week treatment with linagliptin was 0.7% compared with 0.245% for voglibose. Okay, with a confidence. So you are giving the mean and SD. What was the fall in both the groups? And you are telling that the confidence level of 95%, power of 80%, the calculated sample size was 78 in each group. And statistical package uses ZenPepi, and you're going to quote the article at the end in the references. This is what you're going to write in sample size. Okay, so I have covered all the things that are there in the statistical issues. I have hurried through the presentation because my main aim was to concentrate on what you're going to write in your synopsis. We are going to have separate workshops for only those who are